Hello everybody and welcome to Unit 3's project. So this is where we actually get to practice our Python programming skills and apply some of the knowledge that we learned in the earlier videos. So in this project we're going to be developing a K-means clustering algorithm that we're going to use to separate some distinct clusters in simulated data. So once again, this is going to be done in a Jupyter notebook which uses Python. We're going to be using Python 2.7. We're going to use the scikit-learn library to implement these different algorithms. If you followed along in my first tutorial that we did in Unit 2, when we were looking at supervised learning, a lot of this should be reviewed, so we're going to go through it pretty quickly. The first review being the use of conda. If you don't have the packages we need installed, it's as easy as typing conda install, and then the package that you need. Noting that to do this, you have to have conda in your path variables, but that should already be set up and good to go. For this, I'm going to go to tutorial, and then so when you're opening a Jupyter notebook, wherever you are in your command prompt is going to be where the notebook opens. So I could actually back all the way out and then open this from my user folder, or maybe from documents. Wherever you type Jupyter notebook, that is where it is going to open. So I'm going to open this here in my tutorial folder, and we will get this going. So it's going to do its thing and open. It's going to go pretty quickly here, which is nice. Here we go, and I am going to pull this out. Alright, so we have an empty folder. I'm going to start a new notebook. Picking the kernel again. You probably only have one kernel available. I've got a couple because I've set up a couple of different environments, and that is again one of the many benefits of using conda is that you can generate new environments. Alright, so let's give this a title, Unit 3 projects, and we are going to be doing K-means. Alright, so to start any programming project, you're going to import the necessary packages. I'm going to do an import sys just so that we can check and make sure. I'm going to do print sys version. It's always good to make sure you're using the version that you think you are. Here we go. Yep, Python 2.7. That's great. That's what we want to use. It's most common in industry. All right, so here are the libraries that we're going to use. We're going to be using, once again, NumPy. And NumPy is used for computational problems in Python. It's very valuable, especially when you're dealing with arrays and vectors like we will be in this machine learning project. The next one is matplotlib. PyPlot is great for visualizing data, so we're going to use it for that. And we're also going to use the scikit-learn library again, specifically the K-means algorithm. So in machine learning, scikit-learn in Python is paramount. This is what you're going to use the majority of the time. So let's go ahead and, again, Shift-Enter to evaluate a cell in Jupyter. Good. All of those are imported and installed. Once again, if you don't have one of these packages installed, although you should if you followed the previous project, it's as simple as going into your command prompt and then typing conda install whatever package you need. All right, so let's go ahead and generate our data, and we are going to use two means here. So first step, making the data that we are going to do the clustering on. We have the advantage in that we are going to create our data. So we're going to have some better understanding of its underlying structure. So to do that, we want to start by generating a couple of different means for our different distributions. And we are going to be doing a random multivariate normal distribution. And I don't want to know all the details, so I'm going to let it generate a random mean here. And we're actually going to do this twice so that we can have two clusters in our distributions, and that will help us actually have data to separate. We could do more than two clusters if we really wanted to, but for the sake of this tutorial, we'll keep it relatively simple and only do the two here. So here's when we're using NumPy to actually generate our random multivariate distribution. And it has these very convenient functions that get used all the time. And it's just going to be, oh, I forgot my covariant matrix. Before we do this, we're going to have to make diagonal covariance. There we go. And so we got to specify this in matrix notation first so that it can know what type of standard deviation it should be using for these different distributions. So we'll do that now. Here we go. It's as simple as that. So a standard deviation of 100 in both the x and y directions. There we go. Now we can have our covariant matrix here. We're just going to do 100 data points. And we're actually going to do this twice so that we can have both of our distributions here. And this second one's going to be based on our second mean, which I failed to rename up here. So here we go. 2 means, 2 distributions. Let's go ahead and append those together, once again using NumPy, so that we only have one set of data. Here we go. Y1, Y2. I accidentally put Y here. This should be X2. There we go. So our X and our Y, we have both of those. And once again, this is a machine learning application, so it's pretty important that we understand our underlying data before we apply our algorithm. So let's go ahead and plot this before we get started using the PyPlot from Matplotlib. And we're going to make these axes equal, so it'll be nice and square. And PLT just show, this will bring up our figure. So let's again shift enter to run this cell, see if we've got everything correct. And we do. All right, so here you see pretty distinct clusters. I'm going to actually move these in a little closer to each other so that they overlap a little bit more. And that way it'll be a little harder for our algorithm. It's not too impressive if our algorithm can separate these two clusters. Those are pretty obvious to see. But let's see if we can get something that overlaps. I like this one a lot. This is perfect. Some of these points in the middle here are pretty ambiguous which cluster it belongs to. So this will be a good set of data for us to apply this K-means algorithm to and see if we can actually separate them out. All right, so let's keep going. We have our data, but first we want to combine it into a NumPy array of just X and Y data. And you can do that with the zip. The zip will keep this as coordinate points. So that should be good to go. Yep, there we go. All right, and now we're actually going to be making our K-means model. So this is when we actually start applying the machine learning to this data. And so the scikit-learn library makes this very easy. We can just initiate a K-means model here, and we're going to specify the number of clusters. We have the huge advantage here that we actually know what this number should be. Sometimes you'll have to search for it, but for now, since we know it's actually 2, we're going to try to separate this into 2 clusters. So let's initiate this. There we go. And then what I'm going to do in this next slide, or this next cell, is fit the model to the data. So to do that, again, very easy using this library. Simply fit, and we're going to fit this to our X, our input data here. So let's go ahead and run that. Excellent. So the K-means, the algorithm, automatic. It's going to do 300 iterations here, and looking for 2 clusters, and that is exactly what we want. So it's going to output some different features here. One thing it's going to do is find the centroids, the center of each cluster, and to see those we can just pull this up using cluster centers here. Again, just a feature of the package. And then it's also will have labels for each individual data point. Which cluster does it belong to? We only have 2 clusters, so these labels are going to be a 0 or 1. So let's print these out so that we can see them, our labels, and then print our centroids. All right, let's see if we've got everything here. Excellent. All right, so we have 2 cluster centers, and here those are X and Y data. And here are the labels. And this makes sense just because of the way we created this data. And remember, we appended it to the end, just X1 and X2. So the first half of this data should be from our first mean cluster, and the second half will be from the other one. So you see there's actually some that are classified with the other labels, and that's because of the overlap in the middle. But once again, data visualization, incredibly important. So let's keep going and visualize this data. So colors, we're gonna define a set of colors here. So we're just going to do green, and let's also do red. 2 clusters, so we only need 2 colors. If you end up adding more means, just to see this example with more clusters, you're gonna have to add a color here. All right, and then let's iterate over this data and plot it with each iteration. So for I in range, and we're just gonna be using the length of X here, so the length of our inputs. So for each input, we're gonna do a pie plot, and that is plots, and we are gonna want our X data here. So this is gonna be X of I of 0. So first input, second input, third input of the X here, and then on the corresponding Y value of this right here. And remember, this is a matrix notation, so our first index is 0, our second is 1. All right, and then colors, we'll have this draw from the labels, so it will color it according to whichever cluster it was classified as. Marker size, just make our graph look pretty. Okay, we'll come down here and we'll do a PLT, we'll do a scatter plot, 2 T's in scatter. We're also going to plot our centroids so that we can see where it is picking the center of our clusters. And again, just the X and Y data here, 0 and 1. All right, so marker, let's make these actually noticeable so that they stick out from the rest of our data. So do a side, we'll make these pretty big at 150. And Z order, we want these to be in the front so we can see them. All right, once again, PLT.show to bring this up. So drum roll here, let's plot this. Here we go. So 2 clusters separating, the red on the left, the green on the right, 0 and 1, and we actually have these blue X's here are marking the centroids. So this looks pretty good. It did a pretty good job of separating these into its 2 classes. Another way that we can compare how well this did is by comparing the centroids to the actual means. You know, we've got the unfair advantage of knowing what it should be. And remember, the success of unsupervised learning algorithms is kind of hard to classify. Who gets to dictate if this was a successful clustering algorithm or not? It's harder to say. So the results are semi-subjective, but we can compare it to the actual means since we were the ones that generated the data. So here we go. We have the centroid here, very close to our 429, and then 4026, very close. So it's off by about 1 or 2, but not bad considering the spread of our data and the corresponding characteristics. So that's K-means clustering in a nutshell. If you want to go back, add another mean, please do. 2, 3 extra means and try to separate this into more than just 2 clusters. You're going to have to add a color here, change the number of clusters that you're using in your algorithm. Remember, this is just really straightforward to implement because the scikit-learn library makes using these algorithms very straightforward. Some of the data preparation stuff using NumPy. NumPy is very, very valuable. NumPy gets used in almost all machine learning applications, so getting familiar with NumPy and its capabilities is also very important. So that's K-means clustering. Thank you for participating and listening and following along. We're going to move on to Unit 4, where we get to talk about neural networks and deep learning, so that is going to be equally engaging and just as exciting. So keep listening. Thanks.